What's up, YouTube? Welcome to another video. Today I'm going to talk about WebAssembly, and I'm going to share a little about a project that I accomplished using WebAssembly and how I did it. But first, let us do some background. About 2 years ago, was it 2 years? I'm not sure. I gave a talk at GDG DevFest about WebAssembly beyond the basics. And yeah, I think it is a good idea to start by just going through it. So it's over here. So this is how the talk went. So I'm going to do a small recap, and this is the first time I'm looking at it ever since I did that presentation. And let me see what I knew back then and what I know now. And yeah, let me just see. So here is the presentation. Let us try and go through it. So the title was WebAssembly Beyond the Basics. Thanks GDG for giving me this opportunity. Thanks DevFest Nairobi for giving me this opportunity to present this. Yeah, it was DevFest 2023. Right, by Stanley Masinde, Nairobi, Kenya. All right. So I went ahead and defined what WebAssembly is. I'm not sure what I said back then, but right now, if you ask me what WebAssembly is, I tell you that it is an extra compilation target for your binary. Yeah, so how does it do that? Maybe we'll get deep into that later, but just keep in mind that this is what WebAssembly is. The same way you can ship to Linux or macOS is the same way you can ship to the web, so that you can reuse your core logic on the web too as an extra platform to deploy to. Yeah, so the title was Beyond the Basics, of course, uh, just beyond the definition and what else can happen after that. All right, I didn't even bother to change the title here. So here I talked about WebAssembly modules, I talked about use cases, and who is using WebAssembly. Now, I don't remember exactly what I said about WebAssembly modules, but I hope in today's video I'm going to be able to cover them to see. Yeah. So this is just to show how you could use WebAssembly, and the best place to use them is inside the web workers, because web workers don't run in the main thread, and because one of the main reasons to use WebAssembly is because you're targeting performance, and you don't want performant things in the main thread. So you want them offloaded somewhere. Then how the main thread communicates with the workers is via their own form of IPC called posting messages and receiving messages from the worker. Then I, of course, talked about the use cases of WebAssembly. So as one have mentioned, WebAssembly is mostly ideal for reusing logic from your native applications. So let's say you want to process images, and most of the image processing libraries or frameworks are written in native languages like C, C++, because but you as a company have built this core technology that works well in the system, and now you have a web version and you want to reuse that logic without calling the server. So that is one of the use cases of WebAssembly. And I'll give examples on companies that have already done this, which I know I gave 2 years ago, so that it can make more sense to you. Yeah. So also WebAssembly is not constrained only to the browser. There's a thing called WASI, which is full for WebAssembly System Interface. So you can run this .wasm in the system again. So this enhances portability of your logic, kind of like what Java is trying to do or was trying to solve with JVM. Now WASI is able to give you the right one, run everywhere kind of thing, right? Yeah, Java people, this is not an attack. Java is still awesome. I love Java. But I'm just trying to say how if Java was created today, it would be in form of WebAssembly system interface. Just thinking. Back then, it was solving different kinds of problems. But now the best way to do this, I think, would be WebAssembly system interfaces. All right. So here I talked about companies using WebAssembly, and the first one is very popular with techies or unpopular depending on which side of tech you are. That is Figma. Figma, their core logic is written in C++, I think. Yeah. And for that thing to work in the browser, they had to use WebAssembly. Before WebAssembly, they had to do something assembly.js or something for them to be able to run the C++ code base inside the browser. And that is number two is Snapchat recently, about a year or two ago, launched their web platform. And if you use it with a browser that fully supports WebAssembly, like Chrome, you'll be able to do everything you do on mobile on the web, including like filters and everything like that. So that is the two prominent examples I can remember right now. And the point here is that Snapchat has a very special algorithm that needs native to be able to do the things it does. It is not even Android SDK, it is NDK. It is written maybe probably in C, C++. And that is why they couldn't come to the web sooner, because there was no way of doing that in the web. But now with WebAssembly, they're able to reuse that logic in the browser. That is some of the cool things. And yeah, if you have to take away something from this is what WebAssembly does for you. Like, yeah, you can write your core algorithm for a native application, then you can also run it on the web. Yeah, I think I've already mentioned notable project using WASM already, blah, blah, blah. And I think that was the end of my talk. All right. So that is what I talked about 2 years ago. Another thing happened 2 years ago. Yeah, so that is what I did over 2 years ago. I did do this presentation. I was still green on WebAssembly, not that good, but we got there. So over 2 years ago, I also started this project called PW Generator and Open Source 254. And the project went well. Mostly the goal was for, this was way before LLMs. So the goal was for someone could come into this particular website and enter all the necessary information they need to generate PWA quick fast, And yeah, it went well, but I got stuck on generating images. That was the blocker on this particular project. So generating images was a big issue, and I got stuck for a while until recently when I decided to use my newly acquired Rust skills to try and tackle this. Yeah. So let me first of all show you what it does. I hope it's gonna load. Yeah, so it is as simple as this. So all it says, generate your progressive web app, create a complete PWA with manifest, service worker, and optimized icons in just a few steps. Then, of course, you can decide now theme color of your application. Yeah, yellow is trendy, Then the background color of your splash screen. Yeah, we can do that randomly. So this is what will go into your manifest. Then the next step is going to upload your logo. I'm looking for a neutral picture, blah, blah, blah. Let's do this. So this is not going anywhere in any server. This is still on your device. I'm just using the file reader API on JavaScript to read it, create an object URL. So that is what you're previewing here. This has not left your device. And I was so heavy on that to make sure everything happens offline and there's no tracking on this tool whatsoever. And you can even host your own instance. So that was the main goal for this. Then here you configure some things common with PWS, like the display mode. You can decide to be standalone. Most people just do standalone because you want it to behave like an application when you install it in a home screen. Then cache strategy, you choose if you want your application to be cache fast. When a request comes in, it first checks the cache. Then if it doesn't, it tries the network. Then there's network first, and then there's tell or revalidate, which I think is best for dynamic content like a blog or a social media application. Yeah, like when you open Twitter, you'll first see on the mobile, you'll first see some old tweets, then it will refresh and show you that icon, that banner up there, that there are new posts that you can go to. So this is still while revalidate. The choice is, of course, depending on the application. I've given an example. This works well for social media. Network first is, yeah, you want the users to always have content to come to, but you are network first. So if there's no network, you have something to show the users, like maybe an offline page, or you can put a game in there and stuff like that. I'll do another video on PWS. I don't want this to get into that. Then there's cache first. So this is to speed up things. So you do check the cache, and you can keep the cache for as long as you want. For example, you only invalidate the cache when there's a new app version, which is a very good way to make the app feel native, because everything is downloaded, the HTML, the CSS. The only thing you're fetching for the network is, yeah. So this part is not complete. As I've explained already, you see, it can be very complex. But anyway, let us proceed. So here you can now click to generate your icons. And this is the killer feature where WebAssembly really came through uh, to be able to do this. So you can generate all the icons you need for the PWA. It will generate the 48 by 48, 72 by 72, 512 by 512, and you can even add more. And all this has happened in your browser. It has run on your CPU. It has not gone to any other server, provided you have WebAssembly support. Then, of course, you can now download it. It will download your thing, and voila, you have all your manifest and all the other stuff as a zip. You can go ahead and try this. Yeah, so far it just works, and the killer feature that prompted this video is now this. So how did I do this? So generating icons offline was not straightforward. All right, let us look at some code and on how I did it. I want you to pay attention to line 435. So from my WASM image processor, all I'm doing is import the resize square function, nothing else. So as simple as that. All right, so here we're handling logo upload. Then this is just the file API. So the file equals event.target file 0. Then if there's no file, we just return. We fail silently. Then if there's a file, we have a variable on top there called uploaded file. We just set it to this variable. Then we create a new file reader. Then we listen to events. So on load, when the reader is done, then uploaded logo.value, we save this file into memory of the uploaded logo. Then this is how we read the file. So we read as data URL for the file. So this will create a base64 image that you can safely store in memory, which is so cool. Then for us to use our function, we need to convert it into an array of bytes. Um, that's just what's happening here. So our function takes in an array of bytes and returns an array of bytes. Then all you have to do is now just handle it, right? So as simple as that. So for each file that you uploaded up there, we just come and do, we call the resize function. If I can check the function signature, I can say it takes an image data, which is a uint8 array. Then the second parameter it takes is the size, as you can see. Then it will return, of course, an array of bytes. Then our worker in line 694 is to convert that back into an image. Here, I'm doing something hacky. I'm automatically setting it to emg image.png. That should not be it, but it will work. I should change the file type to exactly the original file type is, but you understand now what the blob is doing. And then I read that as URL, then so that I can preview, and I also push icons to my array so that I can use them later to generate the zip file containing all your files. So that's that. So we've already seen how my project works for generating PWS. Now let us go and check on the source code. to see how the program is. All right, let us now check on the source code over here. Yeah, so this is the main repository for this. It has a documentation you can look at, which is still work in progress. It tries to describe what's happening. But yeah, that's not important for this part of the video. I just wanted to show you where the source code is hosted. Yeah, so if you look at cargo.toml, which is a Rust way of describing the package and the dependencies, you can see the authors, all those information, blah, blah, blah. And this is basically what is used to generate the package.json for the JavaScript. So it is not a binary crate. It is a library. Here, if you go back to cargo.toml, the main thing I'm using is a crate called image over here. And you can see the homepage, blah, 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 everything, everything, everything. Yeah, so the image crate provides basic image processing encoders and decoders for common types. Yeah, of course, it is so easy to do this in Rust, but my problem is that I want to be able to use this image crate inside the browser. Now, that is my issue. I don't want to call the network, I don't want to do anything else. I just want it to run inside the browser. And that is where WASM comes in. All right. So let us do a quick thing to see how I'm doing some of the things. Now, remember, yeah, feel free to judge my code, but it is still in early development. I'm planning to add more features like chaining and other stuff. But yeah, that's that. So let us look at the one the normal transformations, which are not color filters. And let us look at the resize square one first, because that is the main function I'm using in the PWA generator. So there are two ways of resizing images. You can resize, and it will try and guess the other part to be as close as possible to the normal resize. So in essence, the normal resize will not be a perfect square, but here we want icons, so we want a perfect square. Hence, I needed to add an extra method that's called resize square to make it more expressive, blah, 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 blah. Anyway, so of course, from the other side, you saw we are passing in the image data, which here now we are seeing it as a vector 8. And the reason why I'm accepting a vector is not because I cannot accept a binary. It is because now here you're crossing language boundaries, and some data types that are available to me in Rust are not available to me in JavaScript. So when you're writing programs that will run in WebAssembly, these are some of the things you need to think around. Yeah. So here, I'll give an example. So if I try and do the image to be dynamic data, the dynamic image as expected by the function, you'll see rationalizer starts screaming. So rationalizer will start screaming at me, talking about missing some traits that will enable this thing to run in JavaScript. And yeah, it makes sense because what does dynamic image mean? Yes. See? Yeah. So when you're writing functions that are going to cross language boundaries, it is good to know what is available on the other language. And here it is as easy as just doing vector 8. So a vector 8 is just an array of bytes. Okay. So what's happening here? What I'm doing, I'm just calling, first I'm trying to guess the format because I want to return the exact format, not to break the image. Then I'm reading the image as the array of bytes. So let me just take you to this function where I'm doing this. Yeah, so the read image function takes an array of bytes that we're going to pass into it, and it returns a result of either a dynamic image or image error. Yeah, so the reason why I'm returning a result is one, I don't want to handle the errors in here. So I'm returning a result. I want the caller to handle it. Here, I'll only return the image if it's found, which is cool. So a result is a way of showing the consumer of this function that this function may fail. It's not straightforward. Yeah, and that is what these question marks are doing here. So if there's a problem with decoding, pass it along. If there's with guessing the format, pass it up. If there's a problem with that, pass it up. Then if everything is okay, we can get our image, which is now a dynamic image, which is the image type for our library that can be consumed. And of course, here we're just writing the test for that, reading a sample image.jpg, then just asserting that the result is okay. This is not a very good test, but yeah, it's a good way to just, when you are doing a lot of refactoring, to just make sure things are working correctly. And also one of the reasons read the image is on its own is because for testability. Now back to our resize square function, which is over here. So of course, we know it will either return an image or it can fail. So because it can fail, if we check out our signature at our return type here, we're also returning a result. JavaScript side expects a vector, an array of bytes, which they have their own name, uint8 array, or a JS value, which is WASM pack way of doing JavaScript errors. Yeah, so a representation of an object owned by JavaScript. So we're going to return a JS value. This is a WASM pack thingy. I'll talk about WASM pack later. Then, because we want a JS value for the error, and the function I told you, read image, might fail. So what we do, we call map error so that we can convert the error we receive into a JS value. And that is exactly what is happening in line 20. So there's a lambda function or a callback that takes error and then returns a JS value from string. Then we just describe it. Then you also pass in on the error. So if something fails, JavaScript will throw an exception. It failed to read image, then it will show us the error. Then a question mark so that the caller can handle it. And this, the caller now is on the JS side. Now they can use try and catch to handle it. So we are not handling errors here. We are passing them nicely to the caller. Not our problem. We're just formatting the errors, which I feel it is cool. If you have any other opinions, feel free to share. But I find this way of doing things very cool. Then, of course, we have our buffer. All right, now when resizing the image, it will not happen immediately. So what we do, we call resize exact, so that we can have the same size. It doesn't approximate then the algorithm. Then it will return a buffer. So as the resizing continues, it will take a long some time depending on the size of the image. Where we created a new vector here for the buffer. Then what you're doing here, you're just writing as new bytes stream in, we write them into the buffer. So that is how we call write to. And write to, we create a new cursor, which is a buffer, a Rust way of doing buffers. Then the second parameter is format. So cursor.new will do the magic under the hood to write our buffer into here. So that is the point of creating a buffer then. Then of course you're mapping the error if the resizing fails, passing on to the parent with this error, blah, blah, blah. If everything is okay, we return this buffer that we just created, which is an array of bytes. And that's it. So this is Rust code utilizing a crate that was meant to only run in Rust. And now we're using it to export it to the JavaScript side. And of course, here we have our test, blah, 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 blah. And yeah, we're good. So we're just testing it out to make sure it does what it does. All right. So how do we compile this? Right? So how do we get this to the JavaScript side? So if I open my little terminal over here, then type WASM build, release, target web so that you can at least see it. And so here, what you're doing, let me first just delete the pkg directory so that we can start afresh. So here, let us build a release with the target of web and see what the JS that will be generated will be like. Yeah, so it is building. using first installing WASM bindgen, blah, 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 and building. So if you go to our PKG, let us just show the hidden thing is. So this is the packet that will be generated, and this can be directly be used in your application. So it generates a TypeScript file that contains a type definition um, of all the methods that you're exporting. So on the JavaScript side, as of course you can see, for example, if you're setting the contrast, it has the comment that I put there. Then the contrast, it will take image data, which is a uint8 array. Then the value of the contrast is a number. So if you're using TypeScript, you're set because the type.d.ts is already there. Then it tells you, it returns also a uint8 array, which enhances type safety. And it also builds a binary. Uh, yeah, this is a binary, that's why I cannot see it clearly in the editor. But now, yeah, this is a binary that can run inside the WebAssembly JVM. All right, then, yeah, this is also just exports for TypeScript. Then, do we have a JS here? Yeah. So this is the JS that will import everything, set up everything, set up everything. Okay. Yeah. So from the talk I gave 2 years ago, that was a very simple way of showing how to do this. But of course, you can see at scale, it will be a problem to do all that other stuff. So to help us do this, uh, the WASM pack thingy you've seen me use down here is what helps elevate the headache. It does all that magic for me so that the JS people can just see what they see. And you don't only have to export it as a normal JS. If you want to publish it to NPM, which is what I'm doing on the production one, I don't know. So if you want to publish, yeah, this happens a lot. Yeah, so if you want to publish into NPM, you use target bundler so that someone can just npm install from somewhere else, even the pkg folder, and use it. And many people use bundlers. We have a lot of things to bundle together and make things performance. The only person who doesn't like bundling is DHH. Yeah, he has some controversial takes about bundling. So I guess the web version will be good for him. All right. So if you go to this place, it should be slightly different because the target is bundler. Like there's some differences I'll show you later, but especially on how you init and other stuff, blah, 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 blah. Yeah. So that's it. So this is how you target the bundler. So yeah, enough of code. Let us move on to, yeah, let us move on to the next step where I can show you how you can quickly get started so that at least you can be able to build something like mine. All right, so the secret sauce for this is WASM bindgen. So it's basically a crate that helps WebAssembly development in Rust very painless. Other programming languages have their own things, like I think Scripten for C++. I don't know how to spell that. I don't know. Google. Yeah, so there's instructions for small WASM files. Yeah, this is too much. This is too much. This this is too much. So I link WASM bindgen, the book, in the description below so that you can see it. But the proper way to get started to just be able to wrap your head around things, just do Rust Rustwasm, and just do MDN. You always add MDN to your links when you're doing web applications. Yeah, it is the law. Don't ask me why, don't ask me blah, blah, blah. Yeah. So there's a very nice guide here that, let me just make it bigger. All right. Yeah. Cool, cool. Yeah, so
Yeah.
if you have some Rust code, you can compile it into WebAssembly. This tutorial will show you how to compile a Rust project in WebAssembly and use it. Yeah, so it is so easy to just follow this guide, which I'll also link below. It can really help you. Yeah, so if you write Rust and you quickly want to get started, this is a very nice guide. I'll link it on the description below for your guidance. And this is exactly how I started. And there's also examples of frameworks that you utilize WASM pack, a tool for building JavaScript packages in Rust. The package will contain only assembly and JavaScript code, so users won't need to have Rust installed, which is very cool. So the users of a package will need to have Rust installed. Yeah, so I'm not gonna go line by line, but I think it is a very cool place to start to just see how things are going and under the hood and how you can bring your Rust logic into web browsers and make things more performant. Yeah, so I guess that's it for today's video. Yeah, maybe I could just mention some of the cool things you could do or people are exploring in the industry. I've already mentioned the utilization of native code inside browsers to power things like Figma, Snapchat, and others. And this kind of logic can enable you to do other stuff in conjunction with other technology like web GPU. Um, you can do things like machine learning inferencing inside the browser and more other powerful stuff. Yeah, so yeah, the goal of all this video was first of all not so much to talk about my project, but mainly to show what is possible. And for the same reason I did that talk 2 years ago, is to spark curiosity. Like, as you've seen, I've not gone so deep into it. It has not been a live coding session. It has been me just sharing what is possible and hoping that someone on the other side of the screen will get curious and start exploring and will make software engineering fun and will make the web great. Thank you for watching. See you on the next. Bye bye.